So today we're talking about chapter 16, which is all about random variables. So you can, X is the letter we use to talk about a random variable, capital X. And if we're talking about a particular value, we'll actually use the lowercase x there. Let's go ahead and get into what a random variable is. Lots of fun casino games we're going to do here. Take out a fixed discrete value. So there are two types of random variables. Discrete are counted. So like anything you could count, like the number of credit hours or any type of countable thing there. 1, 2, 3, 4, 5. Takes out a fixed set. And you can represent that with a histogram. So histogram is really nice for discrete variables. Well, also later in the chapter, that's what we're going to start talking a lot about discrete ones here. But later in the chapter, we'll get to continuous ones, which are measured. These take on all values, all the decimal points in between 1 and 2 and 3 and 4. If you measured the length of a pencil, it could be really any length. So that's going to be a continuous variable, and we'll represent that with a normal curve. So here we are. Here's our first little game here. Flip a coin 3 times, count the number of heads. So you might have to list out the sample space for something like this. Like obviously heads, heads, heads could happen. Heads, tails, heads. Heads, heads, tails. And head, tails, tails. I think we've done this one before. It's pretty popular. I think those are all of the ones that start with H. Let's also do the ones that start with T here. So T, 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 tails, tails, tails. Tails, tails, heads. Tails, heads, tails. And tails, heads, heads. I think we've covered every case. It looks like there's 8 cases. So let's say that the number of heads is 0. So are there any ones where there are 0 heads? Let's see, this one. So the probability of that is 1 out of 8. How many have exactly 1 head? So we've got this one, and this one. So 3 out of 8. How many have exactly 2 heads? I think I did the wrong numbers there. Whoops. So 1 head would be, let's see, this one and this one. And then this one. Okay, let's go to the next one here. So 2 would be, see this one has 2, so that one. This one has 2. Just mark it with a different symbol here. 2 heads is this one. So we have 3 out of 8. And 3 heads is only one of them. It's that guy. And there's 1 out of 8. And that should add up to 1 plus 3 is 4, plus 3 is 7, plus 1 is 8. 8 out of 8 should add up to 100% down there, so we're good. What is the probability there's at least 1 head? So if we have this chart, it makes it really easy to do. So at least 1, we've got, let's see, this guy is at least 1. This guy is at least 1, and this guy is at least 1. So we're going to add up all 3 of those, and we get 7/8. Or whatever that is as a decimal. But that's the probability that x is greater than or equal to 1. We could also graph a histogram of that. It would just be pretty basic. It would be 0, 1, 2, and 3. And this would go up to, at most, 3/8. Probably use decimals, but I don't have my calculator handy here, so I'm just going to not use decimals. So 2/8, 1/8. And it would look something like this, roughly. And this. So you can see that those two have a probability of 3/8, and almost looks like a normal curve. Not quite there, but looks interesting. So we've talked about this first one before. Probabilities are between 0 and 1. You can't have a 1.2 120% chance of something happening. But if you add up all of the probabilities, like we did on the last one, they should add up to 1 or 100%, because 1 is really the same thing as 100%. And so that's just how we check to see if it is a legitimate probability distribution. So here we have AGPAR scores. I don't know if you're familiar with those. Those are for babies. Basically how healthy a baby is. It's a scale from 1 to 10. And there's the probabilities of each of those happening for a baby. You can see there's a lot of scores around 9 and 8. Those are really popular scores for babies. Not quite perfect. I'm guessing Matt, Josh, and Caleb were all 10s, I'm pretty sure. Show this as a legitimate probability distribution. How do we do that? Well, you just take these numbers and add them up. 0.001 plus 0.006 plus ... all the way up to 0.053. And if they add up to be 1, then we know that that is a legitimate probability distribution. Just use your calculator and check that. Okay, so now we get to a little tougher question. We're going to find the standard deviation here. We use our calculator to do that, of course. This is a little different than we've done before. In the past, we just had one list of numbers, like 1, 2, 3, 4, stuff like that. We found the standard deviation. Now we have kind of two lists here. So get out your calculator, and we're going to call the first one value, or just val, I'll call it val. Second one we're going to call prob, for probability. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And second list would be 0.001, 0.006, 0.07. It's kind of interesting how that happened. 0.008. Move this over a little. 5. Let's see. Okay. 0.012, 0.038, 0.099, 0.319, 0.437, 0.053. Okay, so I'm going to go to a calculator page. So I'm cool, so I'm going to hit Control-I. Choose calculator. And by the way, if I want to check and see, let's just sum up the prob. Adds up to 0.98. So I think I'm going to accept that as legitimate because that list, it doesn't add up exactly to 1, but probably some of these numbers were rounded, and I think that's okay. I think it's still pretty legitimate there. So let's go to menu, stats, stat calculations. We've done this before, one variable stats. There's just one difference here. We'll go to number of lists, just one list. It sounds strange, just one list, but watch what we do here. So we're going to choose value for our list. But there's a thing called frequency list. I'm going to choose that. We choose probability there. And so when I say OK, it should give me the standard deviation. What's interesting is it only gives me one of the standard. So you can see here in the list, it only gives you the population standard deviation, which we're not really used to using, but of course we don't have available the standard sample standard deviation because this is a population. So 1.24 is the standard deviation. And so if that question is asked, I would definitely just use your calculator and find it. And it's not that hard. Now 7 or higher is healthy. What is the probability of that? So we really are looking at just these numbers here. So these 4 numbers. So all you have to do here, just kind of like 1 or higher, we're going to add up 0.99 plus, or sorry, 0.099 plus 0.319 plus 0.437 plus 0.053. And so whatever that is in your calculator, that's going to be the answer for the probability of that happening. It looks pretty high. You've got 40%, 30%, 80% of the time or so, you've got healthy babies. So that's good. So now we're to fun stuff here. So expected value. So this is the complex formula. It looks really tough here. X times P. It's really like X times P here. Plus the second X times P. That's kind of like this X times P. Plus however many there are. You just keep on going. So really, once we get this chart filled out, this is really easy to find the expected value. This is the notation we use for expected value. E of X is expected value. So let's try to understand the roulette wheel here. Okay, so on the roulette wheel, you can see there are 38 numbers around the wheel, and 2 of them are green. So there's a green 00, there's a green 0. Half of the rest are red, and half of the rest other than the green are black. And so it says, suppose the player makes a $1 bet on red. So there's, how many reds would there be? Well, half of 36, so it would be 18 reds there. So 18 reds, so 18, the probability of getting this bet, let's see, well, how much would you win? Let's think about that. Probability would be 18 over a total of 38 slots, so 18 over 38 is the probability of winning. There are 18 red red colors for the numbers there. So if you make a $1 bet, you get the original dollar back plus an additional $1. So effectively, you made a $1 bet, you get that back, you added $1, so it's a positive 1. So you get a positive 1, it's 18 out of 38 is your probability. Now if you lose, you actually lose the $1 bet that you made. And so the probability of that happening, well, there's 18 black plus 2 green, so that would be 20 out of 38. This is why we say that the casino has the advantage. The odds are in their favor, not ours, unfortunately. So let's see what would happen. So expected value, if you look at that formula, it's going to be this times this plus this times this. So expected value is equal to 1 times 18 over 38 plus negative 1 times 20 over 38. And you will need to get out your calculator for this one and calculate. And so you can see here that you lose about 5 cents right there. It's a negative number, so you know you're losing money. Right around 5 cents, 0.05, so a little more than 5 cents every time you spend $1. So that's like about a 95% return. So if you spent $100, you might expect to get $95 back. If you spend $1,000, you might lose about $50. You have about $950. So not the worst odds in the world. But the odds are definitely in the casino favors. We know law of large numbers. If you keep playing, what's going to happen? You're going to lose about 5% of your money every time you play, on average. Now another game, there's another type of bet here when you play roulette, which is called a quarter bet. So you can see that you can actually put a chip over there. Like you can take a chip and put it on the corner of some numbers, like there. So if you put on the corner, then you're betting all 4 of those numbers. So any of those numbers, if it hits, you win. But you don't win as much as you would if you just bet it on one number. So you only get your $1 back plus $8. So that's called a quarter bet. So the casino keeps the money. So let's see what you would get if this was the case. So if you win, you get $8. The probability of winning would be 4 out of a total of, I think there were, what, 38? And then otherwise, you're going to lose your $1. You lose $1. And in this case, it's going to be, what, 34 out of 38? So get expected value. This is your X, and this is your, probability of X here. So it'd be x times the probability of x, 8 times 4/38. In this case, minus, because of the 1, minus 1 times 34/38. Get your calculator out.